You're watching TelecomTV's exclusive coverage of the SDN and OpenFlow World Congress event from Dusseldorf. And joining me now is AJ Sahai, who is Head of Technical Marketing at HPE ConteXtream. AJ, nice to meet you. Could I ask, first of all, you're demonstrating here at the World Congress with Intel. What is it you're showing?
Well, first of all, thank you. We have a demonstration that we are showcasing here with our partner Intel, where we are proving to the industry that the SDN and NFV world is moving beyond the POC phase, and we are now, the products are getting to that point where we can start moving into the deployment phase. So what we are showcasing over here is a software switch where we are demonstrating a level of throughput and demonstrating scalability in terms of throughput and number of rules, which is unprecedented.
Tell me about the importance of these OpenFlow rules, because you've achieved a very high number of OpenFlow rules. What are these rules and why is that important?
These are OpenFlow rules. OpenFlow, as you know, is a protocol that was defined by the Open Networking Forum. The OpenFlow rules basically define actions for switches, right? So there's input packets, on which some rules match. They're typically based on 5 tuples, so source port, source destination, source port, source IP, destination port, destination IP, MAC. Those are some of the fields that you can typically match on. Now, the reason we are demonstrating these billions of rules is because you see what happens in operator environments is operators tend to aggregate a lot of traffic, right, in their data centers, and these large traffic streams are comprised of individual flows of a lot of different users, right? And if you want to do dynamic service insertion, you have lots of services of functions that the operator wants to provide. Then the traffic stream has to go through all these functions, right, and before it goes on its way. Now, if you have to take the aggregate streams, right, and you cannot deal with the individual flows, then all the aggregate streams have to go through these functions. It becomes very hard to deal with such high traffic numbers. So what ends up happening in today's network is you define functions, you put physical functions for peak capacity, right? In the virtual world, if you don't want to do that, one of the basic premises of SDN and NFV is that it increases efficiency and resource utilization. You want to be able to manage the traffic more granularly. If you want to manage the traffic more granularly, that means you should be able to take the flows individually within the aggregate and then figure out where they need to go. So that's why the number of rules is important, and that's why we are showcasing that you can do that in a software switch. Now, you might ask the question, why in a software switch? Today, the hardware switches are comprised of, hardware switches have CAM entries, and the CAM entries typically are limited at few tens of thousands, maybe 1 million at max. But in a software, in an operator network, you will find that the million number gets used very easily. And so we are showcasing in a software switch, you can go up to in one software switch, we can actually go up to about 200 million rules. So with 6 of these switches, we are showcasing 1 billion.
So that's how you've achieved that level of performance by using these software switches. Mm-hmm. What features or technologies of the Intel architecture have enabled you to do that?
Right. So, well, of course, we are using the Intel cores, right? So the Intel has multi-core CPUs. We are showing that just by using a couple of the cores, like 2 cores, by dedicating 2 of the cores to this function, you can achieve this high level of throughput and these high number of rules, while having other cores free for other VNFs on the server. In addition to that, we are using capabilities like NUMA node pinning and there's the next generation of the PCI standard. So all these capabilities we are using in achieving this throughput.
You've already said about how using a virtual software switch gives the performance increases to the physical switch, but kind of like what level of magnitude? I mean, what can you do now compared to the physical switch?
Well, so of course a physical switch gives more performance in terms of throughput, right? But physical switches are limited in terms of they are limited in number of rules. So actually in this particular demo, what we are showcasing is that you can have a combination of physical switches and software switches. So the physical switches that we have are the HP 5930s, and those switches can then fan out traffic to a couple of software switches where you can install per subscriber rules. So with a combination of hardware and software switching, you can fan out the traffic. Remember, we were talking about the aggregate traffic. So the aggregate traffic can come in and out of hardware switches, but from there it can fan out to these software switches, and these software switches are where you install all these rules, and you can deal with them deal with the traffic granularly, and fan them out to the various VMs or VNFs that might be instantiated there. So in this way, you can achieve the elasticity with a combination of hardware and software switching. So that's what we're actually showcasing.
So what you've achieved with this demonstration you're showcasing here, what does that say about the state of NFV and how NFV is developing?
I think what it shows is that NFV is getting ready, right? And with SDN with throughput of 1 terabyte and 1 billion rules, this is now getting ready for operator environments, both in fixed and mobile networks. Whether you are fixed, if you're a fixed operator, you tend to have very high throughputs, and maybe so whether it's fixed operator environments, you're looking at enterprise kind of solution use cases, or in the mobile environment. In either case, the infrastructure is getting ready, and this just demonstrates that, and we are very proud to be working with Intel and HPE together to be able to demonstrate this.
Now, final question for you. HP acquired ConteXtream earlier this year. What does ConteXtream bring to HP's NFV portfolio?
So ConteXtream brings this SDN capability. Specifically, we focus on service function chaining, and we have this capability of being able to do a lot of rules. So there are a couple of use cases that we focus on. GI-LAN, EPC POC, and all these other use cases. So we have a couple of applications, and we are very proud to be part of the HP solution.
Great. AJ, thank you very much.
Thank you.